So let me tell you a little bit of the background on myself and Flexera, and a little bit about what I've been doing in the open source scanning world. So my name's Jeff Luszcz. I've been doing open source scanning and analysis since 2003. I founded the company known as Palamita back then, and we just got acquired by Flexera in October of last year. So a little of the capsule history there. I got involved with open source scanning and analysis, and initially in the licensing world, because I was a software developer, and I had worked at NASA, I had worked at big companies, small companies, startups, and I got an experience working with open source back in the 90s, and found myself working in bigger and bigger companies who were using open source, but were having problems complying with the licenses. They didn't understand it. They saw it as free, but they didn't see the obligations and the implications of using it. And I was actually working at a startup where we had a pretty serious open source problem where the product that had been built was based around an open source license, an open source library that wouldn't have allowed us to sell the company, wouldn't have allowed us to sell the product. And we had to do a lot to fix that and unwind it and whatnot. And that was basically my kind of a really reinforced how big of an issue this was for the industry. And I said, once that company was over, I said, I'm gonna build something to help us deal with this. We all love open source. We all use it. What our data shows is that most products are about 50% open source right now. We love it. We love using it, but everybody sees the free side. They never see the obligation side. They don't see the management and care and feeding that you got to do. Let's build a device. Let's build a software product that scans it, lets you manage it, and everybody will be happy. And that was back in 2003. Now I've been doing it now for 14 years, and Flexera has now acquired us, seeing the value in this. And at Flexera, I think if you're familiar with what we do, we help with people who build software and also people who use software, kind of with all the care and feeding and management of it. How do you make money from it and monetize it and put license keys in? How do you figure out if you're overpaying or underpaying for the keys, on the usage side? There's a security wing with the Secunia company that was acquired about 3 years ago. And then now on what used to be Flexera is now what we call SCA, for software composition analysis, basically third-party scanning. That allows us to kind of help both what we call the producer side, the people who are building software, and the consumer side, the people who are using software, to basically keep things straight and to get ahead of licensing problems, get ahead of security problems, especially in what we call the post-Heartbleed world, where people understand that they're really undercounting their open source usage, their commercial usage, but there's a little bit of paralysis. People are trying to figure out where to start and how do they do it. That's where I'm at.
It's actually interesting because this week I've been doing some contracting work for I don't know if they're considered large or not, but what I'd consider a largish enterprise company here, and one of the teams I'm doing some work for wants to open source a CLI tool, and I was actually helping them collate the third-party licenses file, and have been going through exactly this process. And the legal team's like, who does this code belong to? And you go to the repository like, I have no idea. They haven't got any information.
No clue. Yeah. Exactly. Should give us a call. Give us a call. We can help. We have a team that'll do that.
They possibly have their own solution. I'm not sure. It would be interesting to know. Yeah. I don't know. I might ask them tomorrow.
Okay, sounds good. Yeah, and that's exactly what we do, and that's exactly the state of the industry right now. Is that it's done afterward. There's a huge technical debt. It's not like breathing in the sense of, we consumed open source, we managed it, we push a button, we get the third-party notices out, and we didn't pick anything bad because we did everything mindfully. It's kind of like, oh boy, what did we build? How do we fix it? How do we ship it? How do we remediate and fix it? And a big part of what we did, and still do, was a consulting business around this because of this technical debt, because of this lack of knowledge and education, you still see even major companies, top 10 software companies in the world saying, we need help. We want your scanning software, we want your database, and we need your expertise to help us either make heads or tails of this or be as an independent kind of outsourced team to really tell us what's going on, just like what people do in the security world. So I draw a lot of parallels between the security world because it's the same type of thing. There's scanning solutions, there's databases, but there's also this need for expertise and independent view of, did we do the right thing? Hey, we didn't know enough. We didn't know what to do, so we built something that's problematic. Well, now we don't have enough knowledge to even fix it, and that's again where people come in, both knowledge of tools as well as knowledge of the licensing world, the security implications, and how other companies fix it, and where do you start? So that's a lot of what we do as well. Is beyond just selling the product is this whole education, best practices, and just what is step one, which is sometimes this paralysis that people have around security. They have it around open source scanning. It's what do we even do to start? And are we going to get ourselves in more trouble by even doing anything?
Just for the people who this sort of side of developing an open source tool is a little new. What does kind of your tooling or your platform or your solution look like? Like how does someone use it, and what results do they see at the end?
Sure. And there's basically a couple steps that people do. The first step is building an inventory. So what do we have? Kind of this, like if you looked at there's a lot of analogies in the physical world, like you're building an airplane or you're building an engine. What are the bolts? What are the gaskets? What's the lever? Where did they come from? Who built it? Software is exactly the same way. So your first job is to build your inventory. People call it the bill of materials or the inventory list. And there are some things that are easy to find. So the quick scan, very automatable things. So you run a scan and it says, oh, I find these jar files. Oh, I find these DLLs or these RPMs, these libraries, especially if they're coming in from repository managers like Maven or NuGet or RPM, NPM, things like that. So build that. Very often, I did a quick scan. Oh, here's these libraries, Tomcat, jQuery, etc. That's about half of your true bill of materials. The other half of your other bill of materials comes from more complete scanning or deeper scanning, where you look for things like cutting and pasting, stolen images or icons or sounds, binary files that have been statically linked together, just the whole supply chain of, I got a commercial library who wrapped up stuff from other commercial vendors and open source and so on and so on. So you have this like hidden OpenSSL library wrapped in something that you think is purely commercial. So what does our software do? It scans through all those resources, source code, images, icons, binaries, CSS files, builds half that bill of materials automatically. This says, here's what you got. And then for the other half, it shows you the evidence and says, we might have to go break some ties here, or you might need to do some additional deep dives, but I find some things that are clearly third party. Let's go, we'll walk through figuring out where they came from and what's their licensing status and so on and so on. But that's kind of the two phases here. The automatic bill of materials, where you then say, I like it, I hate it, I like it, I hate it, as you go through each item. And then you break some ties on the evidence and you build the remaining bill of materials from there. So that's the inventory building side. People then deal with the other aspects, which is what we call policy. So where you say, I like this type of license, or I like this particular version of a component, or I hate this version of a component because of known vulnerabilities or whatever it may be. So then you train the system to say, show me a Christmas tree. What's allowed, what's forbidden, what we haven't decided yet. And you just do the care and feeding as your developers continue to work on the product or build the product or update the releases. You see how your Christmas tree changes as time goes on. Maybe new vulnerabilities are found out in the field for the stuff you're using already, and what used to be a green turns red. You then upgrade those pieces so you stay green as time goes on.
I spoke to a company a couple of weeks ago who were doing something similar-ish just for Node. So what platforms and languages do you support?
Yep. So we support Basically, pretty much any of the classic, what I'd call application development platforms. So Java, C, C++, C Sharp, JavaScript. We also support things like Fortran, TypeScript, things like that. So both the classic app languages, Perl, Python, as well as the scripting languages. And so what our view on the world is there's very few single platform companies. There's very few companies that'll go out and say they're only Node. There might be an app that's only Node. But if I go look at a Microsoft or a Cisco or a whoever, they use everything. They use everything from Fortran to Ruby. They use everything from literally Ada to whatever. And there may be some places you got to focus on: Java, C Sharp, Node in the Node, JavaScript in the Node world. But it's rare that we ever find a single language or single ecosystem product or company. So our philosophy is to try to go as wide as possible, support as many languages as we can, as many ecosystems as we can, and use as many detection techniques as we can. So try to leave no stone untouched.
So this is, I guess, kind of the business so far, and I guess possibly a newer space for you is looking at how a lot of this applies in IoT and Internet of Things. And this has actually been a recurring theme that has come up in a few interviews I've had recently of, I guess, IoT has exploded in whatever it even means, but it's exploded.
Yep.
And now people are kind of saying, oh, holy crap, now we actually need to figure out how to control it a bit and how to manage it a bit. So explain kind of what the company's thoughts around this are.
Yeah, sure. So IoT is a huge focus area for Flexera in general, and especially for the SCA world. What I think is interesting about what we call IoT is a couple things. One is traditionally those are distributed apps, distributed products, very often with a hardware element. Not always. There's a coordination side and back-end servers, but a lot of what we talk about in IoT is a device that goes out the door. And that device is going to have an operating system. It's going to have a firmware. It's going to have services. It's going to have an app running on it, sometimes multiple apps. The concerning thing is they're all faceless. They're all either have Ethernet or Wi-Fi. They're all running basically 24/7 with power and a pretty fast network connection on it. So, and they're out there and they're faceless. So they're excellent hacking target. And what we've seen in the IoT world is the security traditionally has been an afterthought. If you go look at the latest, the more recent IoT hacks like Mirai and others, they really weren't. It wasn't like the computer science attack of 2017. It was things as basic as, we're all using username password. Okay, we can take advantage of that. Like the hackers and the crackers did not need to go out and do crazy levels of reverse engineering to take over these devices. And we're still seeing those attacks still be fruitful. And then we're starting to see the next generation of, let's get in broken SSL. Let's get in with a broken BusyBox or another open source component. And that's where we see a lot of these devices. They haven't paid a lot of attention to patching and upgrades, or their user-based upgrades, and nobody's ever going to take their IoT device off the wall and apply a patch to it. So how do you manage that? And then from a SCA perspective, from a scan perspective, they're so complicated. They have an operating system that's typically like Linux or another C-based custom RTOS. You have a lot of open source because these are low-cost devices, so people are not going out and spending a lot on commercial libraries. They often have limited resources, so people are going and they're cutting and pasting and they're taking the best bits because they have limited RAM, disk, processor speed. So you end up with this stew of open source that's just been ripped apart and cut apart and then jammed in there without attention to upgradability, without attention to licensing or security for the most part. And that's actually, it's excellent for us, but it's something as a person who uses IoT devices, I kind of, I went to Fry's, which is a big electronics store here a couple months ago to buy a security camera. And I just looked at the wall there, and I saw like $19 Wi-Fi cameras and $25 power over Ethernet surveillance cameras. I'm like, that doesn't buy a lot of security testing. $19 does not buy a lot of quality, and that's that's kind of the state, I think, of IoT right now. Is get out first. We'll fix it. We'll fix it in post production, as they say.
So, I mean, how are you intending to try and tackle this from a sort of centralized way, or something kind of standard platform, or like how are you thinking? Yeah,
a couple things. One is, we've designed our product. So we have a product called Code Insight, which is our main scanning product. And what we bring to bear, there's a couple things. We bring to bear multiple languages and multiple detection techniques. So say you're using C and Java and Python all on the same device. Things like that are very common. We can help you find that and manage that. We've gone out and collected Linux. We've gone out and collected ECOS. We've gone out and collected other RTOS systems. So when you scan, you say, hey, I see evidence of stuff that you weren't paying attention to. And so our product has the signatures to help discover it, has the detection techniques to help discover it. Our company also provides, the training and best practices. So if you're an IoT creator or producer, you can come and you don't just buy a software product. You can buy best practices. You can buy yourself kind of into our ecosystem of other people who are doing the same things. Here's the training they got. Here's the webinars. Here's the white papers and guides. Because a lot of people are doing this for the first time. So that's the big part of it is the products that we produce. And then we also have other aspects of the Flexera story. So we have other security products like the Secunia product, which is really helpful for protecting your monitoring your security status once you've shipped your product. We have things like our ability to do upgrades and what we call monetization for these devices to help with patching and just knowing where things are and for permissions for use, et cetera.
But I get so you're still sort of mostly depending on the vendors to sign up to something like this. The $19 security camera is probably still not going to, I guess. But
right. And I think
what
part
can
of
you
this
do?
is around
I suppose
the ecosystem.
it's kind of
yeah, exactly. And what I'm seeing is people are starting to look at the software and hardware ecosystem, supply chain, and say, $19 doesn't buy us a lot. If we go look at two vendors, price is important, but also things like show me your open source bill of materials. Hey, I always have this test. If you have an Ethernet cord and you have a power cord, you're running Linux, almost certainly, or you're running some other open source. And if you ask that company, give us your open source bill of materials, the same process that you're going through right now. And if they say, huh? Or they give you a list of like 10 things, you know that they're nowhere near compliant. And so we're starting to see the hardware and software ecosystem start to look at things like that. Give us your bill of materials. Look for things like how old is your copy of OpenSSL? OpenSSL ages out every 6 weeks. If your version is 4 years old, you know what? You're not paying attention to security.
So, I guess you've obviously just kind of merged with a larger company, and that's pretty new. But we've already talked about the IoT thing as well. But in addition to that, is there anything you're working on at the moment that you're particularly excited about, or in the future plans that you particularly want to mention, or have you covered most bases?
Well, I'd say a couple things. We have on the SCA side, we have a couple things. We have two products. We have what we consider our on-ramp product, which is known as Code Aware. And it's really designed for this, kind of your first generation on-ramp to scanning. And then there's our other product called Code Insight, which is oriented toward more enterprise features, deeper scanning, especially if you're in the IoT world or the Linux world, you want to use that deeper scanner because you need to get to the Linux level and the source code fingerprint level. So having both an on-ramp and the enterprise product is something that's new to us. It's something we've added to post-acquisition. We've built that on-ramp to work with the existing Flexera install world. So Flexera's had 2 decades of working with companies on installers and part of that build process. And we've added our scanning to that. So people who are doing building, the build engineers who are working in that world, they now have an easy on-ramp, which is a nice way for them to do more than just building. Also, since they're the last people that touch stuff before it goes out the door, it also gives them a chance to say, hey, we might be shipping stuff that we don't know about. So that's one thing. Our security side, so it's not just licensing, but it's the problems. So like, what's the next Heartbleed, et cetera. We're doing some interesting work with our Secunia side. So not just giving alerts to people, but also doing some research into what open source projects might be affected by these subcomponent problems. So we just did that with the Struts 2 vulnerability that came out that got a lot of press. So we worked with Secunia to not just look at the commercial products, but we found a list of about 1,800 open source products that were not making the news that were likely affected by this vulnerability as well. So we were able to publish that data to the banking industry and the enterprise industry so they could get ahead of that, basically potential concerns even before the other alerts went out for those open source projects.
Yeah, okay. I mean, is there an ability for you to preempt some of these potential problems, or hard to do that?
I think there's a couple of things. So there's Secunia, who is part of Flexera, who is doing basic research into new security holes and what their impact may be. So as our company, we have that in our DNA. We have people who are doing that. And then on the SCA scanning world, we're able to use that information to alert our customers, basically as soon as possible. But then also, because we have this database of over 100 terabytes of open source code and releases and things like that, we're able to use their basic research plus our basically massive database of over a decade of open source data to look for, basically get ahead of problems that haven't been reported yet. So what products were using struts that didn't report that they themselves had a problem. That type of data is available for us.
It's an interesting space, and it's strange how I've interviewed maybe sort of half a dozen companies doing various aspects of this process recently, and I guess it's good that it's becoming more mainstream, but it's also a shame the reasons why, I suppose. That it's only thanks to so many high-profile vulnerabilities and how much of an impact they have on society now. I mean, it's gone beyond just, it's an inconvenience, to actually like almost on the verge of crippling infrastructures.
Yeah. Yep. There is a chance. Yeah, it's a chance that any day we could wake up and somebody says somebody took down the power grid. Why? Because of OpenSSL, or because we weren't paying attention to X, Y, Z. We do a lot of work in the automotive and autonomous vehicle software ecosystem right now, and this is one of their big drivers. They have 2 big drivers. They have the legal aspects, which is, we don't want to, we can't recall a car. If we recall a car twice, we've lost our profit on that whole line. So they don't want to recall it over an open source issue. But then if you look at the cars, they got 12 Linux devices in them, 12 full Linux machines, all with networking, all with cameras, microphones, radar, LiDAR, the ability to steer the car, brake the car. And they're looking at this saying, we don't want to be the poster child for, autonomous vehicle goes awry. Or we don't want to be the poster child for, everybody's been listening into the Hollywood movie stars' microphones for the last 6 months because we didn't do our basic due diligence around open source, vulnerabilities and things like that. So it's interesting how behind the scenes a lot of these companies, because of the security concerns and privacy concerns, are starting to pay attention to this. And it took Heartbleed really to open people's eyes to how big the problem was and open up the disconnect between management saying, oh, they must be doing the right thing, and engineers saying, oh, somebody must be paying attention. And it turns out that nobody was.